Okay, let's look at using an elimination strategy to solve a system of linear equations. And the first thing to do is to stack everything so that they're all nicely lined up. Okay, so I've got 2x plus y equals -7, x plus y equals -4. So this is kind of like when you started adding multiple digit numbers in elementary school. Remember, you had to have all of your columns lined up or it didn't work. So I have to do the same thing. They have to be in the same order. The equals have to line up. Okay? And then I'm looking at this and I've got the same number of y's in both equations. And so that's what I'm going to eliminate. And if I add my two equations, I'll have 2y's. So I need to subtract it so that I'm going to have y minus y. So it's absolutely essential that I put giant brackets around the second equation because I'm subtracting that. This is like I'm subtracting polynomials, except I'm doing it stacked. So I put the big brackets, I put a great big negative sign out here. If I don't put the brackets, then I'm really only changing this x to a negative x, and I'm subtracting that, and then I'm going to add those, and that's not what I need to do here. Okay, I have 2x minus x, that is x. I have y minus y is 0, so I could put plus 0, but you know, mathematicians are lazy, we don't do that. And then I have -7 minus -4, so that's -7 plus 4, which is -3. So there's my value for x. And then I'm going to take that and substitute that into one of my original equations. And it doesn't matter which one. I'm going to pick the 2x plus y equals -7. So that's 2 times -3 plus y. And I get y equals -1. And then I have to test it in the other original equation, which is x plus y equals -4. So I had y is -1 and x was -3. There's my answer. Box around it. So I'm going to test that. So -3 plus -1, that should equal -4. And it does. Okay? Always check. Oops, that's not how you spell always. Always check. Okay? It's really important that you check. Okay? And you always test it in the other equation. Okay? All right, what it really looks like. I'm going to do another example, but this time I'm actually going to add the equations instead of subtracting them because this time I've got a -5y and a +5y. So if I add those, I'm going to it'll equal 0. Now it's a good idea to just do the brackets anyway, but you don't have to have them when you're adding. But if you just make it a habit to always do them, that's a good thing, right? So 23 minus 9. Okay, that's what it really looks like. Okay, this time I need to multiply. This time the coefficients aren't the same. So I have to multiply something by something to get the coefficient the same. And I notice that if I multiply the 2 by 5, I get 10. So I'm going to multiply this equation by 5. Now make sure that you multiply every term by 5, otherwise it doesn't work. So I get 30x minus 10y equals 110. The second equation doesn't have to change. That's still 5x plus 10y equals 30. And I'm going to add them because one's a minus 10 and one's a plus 10. So if I add that, it's 0. So 30x plus 5x is 35x plus 0 equals 140. So I get x equals 4. And then I go to my other, now I need to find my other values. So I'm going to pick an equation. The rest of it, again, is the same. So I have 6x minus 2y equals 22. Substitute in my value that I have for x. I always check my answer using the other equation. So 5x plus 10y equals 30. Okay, so I'm happy with that answer. All right. Final example for this. This time, neither of those is a multiple of the other, so I have to multiply both equations by something. Okay, so I'm going to eliminate my x's. I could do either one, but I'm just choosing to multiply the x's. So I need to multiply this equation by 5 and this one by 3 so that I end up with 15 x's both times. So I get 15x minus 20y equals 35 and 15x minus 18y equals 24. And then since they're both pluses, I need to subtract. But can you see if I don't put the bracket in there, it looks like I'm just subtracting the 15x. So make sure you put those big brackets in there, make them really noticeable, okay? So 15x minus 15x is 0, minus 20y minus 18 is plus 18, so that's minus 2y. And then 35 minus 24 is 11. So then y equals negative 11 over 2. So when you get a fractional answer, it's easier usually to just do elimination again to eliminate the other variable rather than substitute in a fraction answer for something. Not always, but you never know. So let's just do it that way, okay? So I'm going to take my original equations of 3x minus 4y equals 7 and 5x minus 6y equals 8. And I'm going to multiply this. I want to eliminate the y's. So my lowest common multiple is going to be 12. So if I multiply this by 3 and I multiply this by 2, I'm going to get 9x minus 12y equals 21 and 10x minus 12y equals 16. This time I can add, I have to subtract them again because they're both the same sign, they're both negatives. So 9x minus 10x is minus 1x minus 12y minus negative 12y is 0, and 21 minus 16 is 5, so x equals negative 5. So I'm going to check in both equations. Okay, because of the way I solved it, I used both equations to find both answers. I need to check in both equations. So I've got my first equation is 3x minus 4y equals 7. So this is my checking. So this is 3 times minus 5 minus 4 times minus 11 over 2 minus 15 plus 22. That equals 7. Yep, that worked. And 5x minus 6y equals 8. So 5 times minus 5 minus 6 times minus 11 over 2 equals 8. So that's minus 25 plus 33. Yes, that does equal 8. Okay, so my answer is negative 5, negative 11 over 2. Okay, there's my solution. Okay, leave it as a fraction because there were no decimals in the question, and that's the rule. Okay, so just a couple of notes. Okay, one, it is okay to use decimals here to check your answer and to use your calculator. That's fine, but do leave your answer as a fraction, as I said. And then if, I just wanted to write this down, that if you get a fraction answer for your first value, it's sometimes often easier to use elimination again to get the second answer, but then you have to check your answer in both of your original equations. That is essential. All right, that's it. Bye.